Hello, guys. Nice to see you early in the morning, or depending on your time zone. As you can see, I have even found my Kotlin cap. Actually, it comes from Kotlin Island. It says Kronstadt on it. But that is not important. And today I'm going to talk about Kotlin and frameworks and how I have used it in the past few years. So it's going to be about Kotlin server side. So Kotlin was initially built for in-house development of IntelliJ IDEA by JetBrains. So as far as I know, but it was later picked up by Android developers who took over. And now I think most of the Kotlin development happens on Android, which is sad because it's so good for server side as well. So server side currently it's not that popular, but it's steadily rising. And I hope if you haven't tried it on Kotlin on server side, you should. I have also tried, or I really wanted to use Kotlin on client side because it can nicely be compiled to JavaScript, but there are some problems with that. Why I'm not using it currently. So the first thing is that it compiles to ECMAScript 5, which is old version of JavaScript, and it doesn't support native classes, for example. And so it's hard to use for some of the things like web components. But if you click this link later, you can actually look at the source code, how I managed to make web components work with Kotlin JS. So it also has a more difficult interop with JavaScript, so it's hard to make it an implementation detail. So it's hard to create Kotlin code, which is then compiled to JavaScript, and you release it to some JavaScript developers so they don't understand that it's actually Kotlin. So right now there are some gotchas and packages and something like non-native field to the code that you compile with Kotlin JS. And it's also difficult to use any UI framework other than React. So there are React bindings, but unfortunately, you cannot use the other ones very easily, like Weld is currently my favorite. So that are the reasons why I'm not using Kotlin on client side currently. So yeah, and another one is the bundle is huge. So std-lib generates a really big JavaScript file. You can minify it, of course, and all kind of things, but it's still pretty big for like smaller projects. And I'm also waiting for WebAssembly target. So maybe at some point we can use Compose, like Google Compose that they developed for Android. It's also available for web now. So once maybe you compile it to WebAssembly, you can actually finally use Kotlin on client side nicely. But before that, Kotlin for me is on server side and client side is TypeScript. I'm going to talk a little bit later about how to integrate them better together. So there are very nice killer features in Kotlin language that actually enable writing things very easily without help of framework. So Java on the JVM, like what is an alternative to Kotlin on server side, they tend to use a lot of frameworks for everything and libraries. So in Kotlin, what I want to claim here today is that most of them are not needed. So the killer features for me in Kotlin is, of course, the nullability and compile time null checks. This is something I miss the most when I have to write some code in Java or any other language. So TypeScript actually has it as well. So then it's quite dry, so you don't have to repeat yourself much. So type inference doesn't need you to specify types twice, and we'll get to that in more detail. Then when you define constructors, you don't need to define separately constructors and fields and then assign constructors to fields. So this thing makes for example, constructor injection very bad looking in Java, but in Kotlin, it's all really nice and clean. Then the immutable data classes. So it's pretty easy to make a small data class for just single use, and you don't think much about it because you can do it in one line. So nowadays in Java there are records, but still, I don't know, probably not many people already use them. Then Lambda with receiver is, of course, the unique feature of Kotlin, which probably is not taken from other languages like most of the other features. And that
yeah, of course it is taken. I'm sorry to interrupt you. Of course it's taken from Groovy.
Okay, kind of, yeah, from Groovy, yeah. This builder syntax is also coming from Groovy, but it's really nice to have it in a type-safe language, where you actually know what is your receiver and what are your arguments and everything. And of course, the extension functions that I use the most to fix the APIs that Java provides or any other libraries provides. So it's very easy to do small fixes, add some small helpers for yourself or for your own project. And of course, the idiomatic built-in functions like apply also, I use them a lot to actually make the code more functional. So I can define most of the functions in Kotlin with the equal sign without the code block and return. So, and reified generics is something that enables really nice dependency injection and this kind of thing. So let's look at it soon, along with type-safe reflection. So about the dependencies. So my overall recommendation is that to avoid as much dependencies as you can, because if you have fewer dependencies in your code, it's lighter, it's much easier to upgrade something like the JVM version or Kotlin version, so other libraries don't get in your way. With Java, it's a constant struggle to actually upgrade some ASM and CG or whatever when you have a newer JVM version released. And of course, down the line, it's much easier to maintain if you have fewer moving parts and only the smaller utility functions that you have written yourself and which are really small and do exactly what you need and not anything else. So any dependency should be very carefully selected for your project. So actually, here I would also remind you, if you're familiar with the client-side infrastructure and stuff, there was a huge problem with left pad library when it was removed from npm package manager, and most of the JavaScript frameworks broke. So if you don't use that small useless dependencies, but just have your own left pad function, which is now in the standard library as well, so you don't have you will never have this kind of problems. So for any dependency, you need to carefully consider, so does it add more value than problems or configuration or etc. So for some of the dependencies, especially the dependency injection frameworks, you actually need to write more code to configure it than to implement the actual framework yourself. So we'll look at it in a moment. So then would it be easy to replace if needed? So if your dependency that you are using is abandoned, or it's doesn't do what you want anymore, or any other reason, so can you easily replace it? If you can't, probably it's not a good idea to use it, because you will need to live with it. And most likely, with Play framework, we have Codeborn, we had to actually become the maintainers of the framework, you can say, because we have used it in several projects and nobody wanted to maintain it anymore, so we had to do it ourselves. So when you take some dependency, especially a framework, you need to be prepared for that. So then like one thing for me is like, I think always, can I implement the same? Is like in about 30 lines of code or something. So if I can, probably I will. So I will not take the dependency, and it will be much easier to debug and stuff. I will know for sure how it works and why it works that way, and I can change it very easily. So, and then of course, if you take any dependency, you need to control its usage. So avoid the dependency to control your code. So this is especially important for frameworks that call you. It's much better to use smaller libraries that you call and not they call you, because these are much easier to replace. And if you take any dependency, also you need to understand deeply how it works in detail, because sooner or later something will not work as you expect, and you will need to fix it or work around it and whatever. So yeah, that's being said, that one big framework that does too many things for you is bad. And this is like, I think one thing that comes to mind here is Spring or Spring Boot, because it tries to do everything what a software developer needs. And of course, once you pick it, you get into the jail of Spring Framework, and you need to do everything what how it wants you to do. And it becomes almost impossible to replace later. So it's much better to pick smaller things which are more focused if you really need to pick something. And think of dependencies as a puppet theater, where you actually the master controlling everything, and not the vice versa when somebody controls you. So yeah, next, what we are going to look at is available on GitHub, and it's called Kotlin JVM Weld template. So it's actually a template I made for myself and my colleagues. I have used it successfully. It's about 3 or maybe now even 4 real-world customer projects. Of course, it's not a framework, so it has some utilities, but when I actually start a new project based on this template, I modified it a lot based on the project needs. So that's the beauty of having code in your own repository, that you can easily change it without worrying to break other users. So if you have a framework, you need to handle all the use cases in one framework, but if you have your own code in your own project, you need to handle only the use cases that you need. So yeah, that's how it works. We can look at it in IntelliJ IDEA. I have opened it here. So it has some README and some links as well that you can look later. And the thing is that it's both the server side and the client side template in the same repository. And why so? We'll get there later, because yeah, you can share actually type definitions between client side and server side, which is really nice. So let's talk now about the dependencies that I have here. So the first obvious dependency that some people don't consider a dependency is the JVM itself. So Kotlin server side, or Kotlin, was designed for the JVM, and this is where it works the best. So it interops really well, and you can use all the stuff that is available in Java Standard Library. And Java Standard Library has a lot of things that you need. So actually, there are a lot of stuff that people do bring with separate dependencies, but you don't need all of that, because Java already provides you with a lot of stuff. So version of the Java is not that important, but because we are writing Kotlin, is backward compatible up to Java 1.6, but I would say that newer is better, because with newer Java versions, they actually make it a little bit slimmer. So they remove stuff nowadays from the Java, and they have some performance improvements and garbage collection improvements, and also, like for example, Java 15 has now better null pointer exceptions, which actually tell you what was null. So before Java 15, you had to guess, but now it's much better, and it's also useful with Kotlin.
Nice thing to know that SAP Java had this feature for like years. from like starting from Java 6, and Oracle has implemented it only a year ago.
Yeah, I really didn't get. I was like also wondering like 10 years ago why can't they do it? But yeah, now it came finally. Okay, now and yeah, the built-in APIs, and also my dream, of course, is to switch to Kotlin native someday because it seems much more lightweight. But the thing is that if you use Kotlin native nowadays, you miss everything that the Java standard library provides you, and as I told you already, it provides you a lot. So actually, it's much easier, like the things like sockets and file operations and whatever, it's much easier to do on the JVM. And the cons of the JVM, of course, is the slower startup compared to like native. So if you compile your Kotlin code to native, you will be pleased how you can run the your program in like microseconds. Probably it will start really fast. With JVM, it takes like still some hundreds of milliseconds to start up, and which is not a problem for server side for long-running tasks, but high memory footprint is a bit of a problem because when I do client projects in Node.js, for example, it's really cool to see how your memory consumption on production is like 100 megabytes, or even less. Maybe sometimes you can get by with 50, but with Java you need like a few hundred at least to make anything work at all. So yeah, and dependency 2, what I have in this project is the Jupyter, and actually Pavel, who is right now here, has actually recommended it to me like maybe a few years back at Kotlin Conf, and it stuck to me, and because it seemed like a nice fit for Kotlin. So for like most of the projects nowadays, you need an HTTP server, and like you can implement it, and I have done it many times, but like to do some of the more complex things work, like especially HTTP2 and stuff nowadays, it's quite hard to do it right. So it's better to take it as a dependency, HTTP server. And Jupyter provides that, and also it provides lightweight enough and simple to use API. So it looks very much like Java Spark, but less static. Let's look at a simple example. So, for example, you can declare your routes like this. So seems pretty nice to me, and pretty lightweight. But this is not how I write most of my code. And the good thing is that you write your own main method. So you call Spark, or you call Jupyter, not it calls you. So so it's easier to replace extend. And as you can see from this code, you can like extend almost everything that you need. You can install new modules that would do stuff for you with before and after handlers. So seems like okay dependency to me. So but the thing that I like the most right now is the compile time MVC routes. So actually, which are really easy to unit test. So let's look at some controller examples. So for example, what I have in this project, like this. So it also supports the annotations, and these annotations are actually compile time annotations. They are not like there are no any like bytecode manipulation at runtime. So when you compile your project, this will be converted into post route, like we have seen before. But because I write my own regular function that handles the request, I actually pass here normal parameters. It's really convenient to unit test it. So if I look at the unit test,
may I ask a question at this point?
Yeah, sure.
I could see the like context and some other things as arguments of function. And how do you pass them with unit tests? Do you mock them, or
this is now the unit test here, and most of the functions, they don't need the context. So actually, it's much easier to just pass something like that. For most of the routes, actually, they are like that. They have only the input. They are basically like pure function. So you pass input and you check the output. So it's really convenient to unit test. You don't need any wire mocks or anything more convenient or more complex. But for this session and context, they are easily mockable. As you can see in Kotlin, I use the mock library with double K, which actually can provide me instances of these guys, and I can really easily tell how they behave, like with this every thing. So for example, and I can verify, like, for example, the session is cleared. So the code is quite clean when I test stuff like that. And the tests don't have to go through all the layers of the framework. So they test, I test only my code. I don't need to test the framework itself. So this is the thing I like about Jupyter. So basically, you return something from here. It will be converted to JSON because I have installed the Jackson module somewhere here. Somewhere I have it. So basically, it will convert the output to JSON by default for me, and I don't need to worry about any of that. So I have like just my code. But then it also have the coroutine support for sane asynchronous programming. So basically, if we look at the routes that I define here, so actually there is this modifier coroutine, which is built in. You can even now, I have actually contributed this pull request to Jupyter that you can now redefine the launch context of coroutines. So basically, you can pass on the MDC and the transaction to your coroutines, and then you don't have to worry about it anymore. So you just write your just mark your routes as suspend functions, and everything works. So that I also really like. It's especially good if you need to consume some microservices down the line, so you can work with them totally asynchronously. So yeah, with as with every framework and library that I seriously use, sooner or later I have to do some pull requests there, but that's normal, and that I did it with Jupyter as well. So maybe in future I will try using just the Undertow server, because I think the Undertow is one of the lightest web servers available for the JVM that also is asynchronous. So maybe I will try teaching Jupyter and replacing with pure Undertow, because writing your own route handler for in your project is also pretty easy. So why not try that? But let's go further. The dependency injection. This is where also most of the people pick some framework. And dependency injection is actually, it's an optional thing. You actually don't need it even in many projects. Although I remember when I first discovered Spring in like, I don't know, early 2000s, I thought, wow, that's kind of cool that actually you can hide your dependencies as implementation details. So for example, if you need user service, you just say that I need user service, and you don't care what does user service itself needs. So that's a good thing because it makes code less tightly coupled, but also you can do dependency injection pretty easily by hand. So I have the dependencies here, but imagine you have your main method. You can also make it like this. So while for example, in this project you create the user repository, you see what it depends on, like you provide it with a data source, you create a new instance of the hashing service, you create a new instance of secure random, then you need to pass it to like your app, and you give it the user repository and all the other dependencies. So basically, you can have a hand-coded dependency injection in your main function, like you just wire everything up, but the user's repository or anyone that uses it doesn't have to know what it depends on. So this is like the beauty of constructor injection, because Spring for years they have propagated the field injection thing or setter injection. which is pretty bad because you create an instance which is invalid, it's not usable, and you need to set some things there like db equal db, only then it becomes usable.
But it is more testable.
What is it?
I would say that setter injection or field injection thing is more testable, because I don't need to pass all the arguments to constructor to mock all of them to test my only to test the single method.
Yeah, but look, like in Kotlin, it's pretty easy. So there is the reified generics here. So if I don't need to test something, I just pass the mock there.
Absolutely.
And I don't care about it. So basically, Kotlin makes using constructor injection really nicely. So you define your constructor parameters. They can become fields if you need. And to test it, like how do I do it? I just create one instance in a user repository test, and I can then test everything. And if I need to verify something, like to mock some behavior, even of the secure random, I can do it very easily and test it. But that constructor injection at compile time, it actually ensures that I'm not missing any of the dependencies in tests. But in production code, I don't care what it depends on, because it is already created for me. But now, like getting back to the framework. So some people would use Spring, Juice, or Dagger, or for Kotlin, I think the nicest like third-party option is Coin. But all of them needs some configuration. And this configuration very often is like more than like 10, 20 lines of code. So for Dagger, when I use Dagger, actually, in one of my open source projects, I replaced it with my custom dependency injection. I think I have deleted like maybe hundreds lines of code of configuration by replacing it with the dependency injection that works by default without any configuration the way I want it in that project. So dependency injection is a really nice thing to do yourself, especially in Kotlin. So most of this are big and bloated, and with most of them you need to fight from time to time. So you need to look why it doesn't work as you expect, and need to like change something. And it's hard. And Java frameworks also, they suffer from annotation abuse. So you need to write a lot of annotations, and they are all processed at the runtime, and some bytecode manipulation happens, and whatever scary and slow stuff. So Kotlin makes constructor injection really dry. So in Java, I don't tend to use constructor injection, because you need to declare field, you need to declare constructor, then constructor parameter, and then you need to assign it as well. So that's you need to declare your dependencies 3 times to make them work with constructor injection. But with Kotlin, it's dry. You declare it only once, and it just works. So it's really nice candidate to do it right. So, and yeah, the classes are easy to test in isolation, as I've shown, and compiler will not allow you to use incomplete instances. So when you have an instance of your class, you are sure that it's completely ready to be used. And yeah, as I've shown, dependency graph can be created manually also, but it's also pretty easy to create it automatically recursively. So that's why I have written this auto-creating service registry. So service registry is something that Juby already provides. So it's nothing really fancy, it's just basically a map. You can see that Juby itself is written in Java. But so it's basically a map where you can ask it for instances. So I think actually the most important method here is the require. So you tell it, I require a user repository, and it will provide you an instance. And by default, service registry is just basically a plain map. But and you need to put instances there by hand. But with Juby, there are some plugins. You can plug in Juice, you can plug in Spring, and whatever. But I decided to write my own. And as you can see, it's actually, if you select only the code without imports, it's 18 lines long. So basically, when I extend the service registry, I can delegate everything to the original one. As you can see, this by delegation feature is quite nice in Kotlin sometimes. However, I use it quite rarely. And then there is one method that I need to delegate that gets me an instance of some service. And as you can see, I delegate to the original one and ask if it has it. Then I return it. If it doesn't have it, I would try to auto-create it, and then I put it. So as you can see, also here is quite nice because it allows this function to be very functional. So and this auto-create service, this is the main logic how the whole of dependency injection works. So basically, it takes the type, it takes the primary constructor if it's a Kotlin class, or it finds the constructor with fewest arguments if it's a Java class, and then you just go through all the parameters. You filter required parameters, because in Kotlin you can have default values for parameters. So in this case, that's fine for me, but this is the logic that can be easily modified for your needs. When you have your own dependency injection in your own project, you can change it at any time if you need a different behavior. And then basically, recursively, I require all the parameters. So basically, if I need one service that requires something and that other service requires something else, so it will go completely recursively until all the requirements can be satisfied. So if something cannot be satisfied, then the service registry will throw a registry exception. For that, I will add here more details, and it will nicely tell me what dependencies I'm missing or what cannot be created for some reason. But for other stuff, it just tells me that something was auto-created. Actually, I wanted even to demonstrate it on one of like real projects that uses the same code, how it works. So when I started, okay, it needs to build. Let's look at the unit test for that, for the usage examples. So basically, yeah, we have the registry, and for example, we have this service that depends on these guys, and we have other services depend on something, and some of them have default parameters. So this all works when I ask for it, require a dummy depending service. It will give me nicely all of these things pre-created. So as you can see, for most of the dependency frameworks, you write more code than this to actually just use the dependency injection framework. But here you implement it and you can customize it really easily. So you can remove the logging and it will be even shorter. So let's see. Yeah, now this one has started. You can see it. This is the Jupyter feature that it actually lists all the routes that they have found, but also for like debugging in production is also convenient. So it will tell me which instances of what it has auto-created this auto-creating service registry. So for example, order routes depends on all these guys, and like I don't need to create it all manually. So it happens automatically and really, really quickly. So for that, I want to tell you like this, the reflection in Kotlin, the Kotlin reflection is also has really nice API. So it's more type safe than Java, and you can do like nice things with that. And but here, of course, is nothing really fancy, but I will have even better examples. So let's go further because we don't have much time left. So the next thing is the ORM. So most projects need to access the database. So yeah, you can go and search for the modern alternatives to Hibernate, because Hibernate is a disaster. It's huge. It's hard to debug. Really complex code, and very often it doesn't do what you want. So it does some dirty checks, it does some implicit saves, whatever, that actually really error prone. So the alternative,
and actually it's all usually misused.
Yeah, it's usually used wrongly. So, and it still requires the ugly annotations on your classes. So the Joke and SQL 2.0 a little bit nicer options, but still they require a lot of boilerplate code. And what I was thinking that I don't want any of this. I know how to write SQL. It's really easy. And yeah, Hibernate also is #1 reason why many Java applications startup time is so long, because this is Hibernate initializing all the classes and doing bytecode manipulations. So I want my app to start in like a couple of seconds, which all of my apps do, and the Hibernate and Spring are not like good for that. So so I was thinking, why not build some nice extensions for JavaSQL data source? So data source is a nice thing that all JDBC drivers implement. There are lots of JDBC drivers, and that's what I did. So let's look at the thing called JDBC extensions in this project. So basically, I want, let's even look at the tests first. So I want my database access to be that easy. So I want to say that I want to query from that table. I want to like with these parameters, and then I want to map my object. So like for so here actually I can create an instance of something, like let's say user, and like I can read here inside of this Lambda, I have a receiver of a result set. It's called for each row returned from a database, and I can use the result set functions here to create my objects, basically. So this is an easy mapper, and this is all achievable with only a few lines of code. So I can show you a real example as well. User repository, I think here it was, yeah. So the mapper is like this. So it actually, this kind of Lambda, it takes the result set and returns a user. You can create a user from the fields in the database. You can do like any logic that you like here if you need it to be different. And then you just use this query thing. And you can see you can even extend the mapper. For example, if password doesn't match, you will not take the result of the mapper. So you can do this kind of nice things. And the code looks is pretty readable and pretty clean. And the same goes with insert. And like even I have the upsert here, which is really useful, that does either insert or update inside of the database. And also the update and delete, all of them are here. So how it's implemented, it's also pretty easy. It's in total, it's like if we don't consider the operators here, which are useful for some cases, it's like also less than 100 lines of code. So you can see that's all of it. It's like 88 lines of code. But the thing is, and it does exactly what I want again, and I can debug it easily. I can change it easily. So so as you can see, there's the query. There are several overloads, like one for ID, and they generate the select for me. For example, when I specify my where as a map, I will just convert this map also to where expression. So I will generate this SQL very easily, and like this, and I support even some things like in operators, and it goes down to the simple binding. So most of these things, they basically, what they do is that they use the JDBC. So this prepare statement is just the JDBC method on the connection. And as you can see, all the methods, they are actually on a data source. They use the with connection, which handles the transaction that I'm going to show you next. And with connection provides me Lambda with the connection as a receiver. So I can do the prepare statement here, or anything else I can do on a connection. I generate the SQL here, or I can provide the whole SQL myself if I want. If I need to do something really fancy with many joins or whatever. And then I just set all the values again from that map. And this is also an extension function on prepared statement that can go through all the values and just set them. So you can see that everything goes to the result set or prepared statement set object. And then nicely I can execute update, for example, or I can execute query if it's a select. And if it's a select, I just map every row with my mapper. And this map also is my extension function here, which on result set takes the mapper and just creates a list and goes through all the rows of the result set. You can imagine all the analog code in Java would take like I would say 10 times more lines. So with Kotlin, you can make it all nice and compact. So that's why it's. I would probably not do that thing with Java, but with Kotlin is just such a nice thing to do. And you can see that inserts and upserts and updates, they are also pretty easy. So they use this exec to, again, generate the statement for me. And I go through the values and set them to the prepared statement. So there's nothing fancy here, just a plain JDBC, but you get really, really nice and convenient API, which is actually quite extensible as well. So you can see you can even do the joins without writing the full selects yourself. So you can still extend here everything and do what you want. So I'm not going to show you more of that. You can always look at the source code later. So let's look at the transaction management, because this is also something that people use. Okay, what I wanted to show you the real ORM that I have also in Kotlin. For example, the same user creation by hand. It actually, you don't have to do it as well. So if we take the unit tests here, actually there's a second test that actually uses that two values. So I have extension functions called two values, which you can call on any data class, for example, and it will convert it to map. And basically you can insert it that easily. And then if you want to query it again, you can use the from values function inside of as a mapper. So in this case, it will actually create an instance of that class. And here the reified generics again to the rescue, because this from values sees the type here, and actually you don't have to specify it. So really nice feature. And the implementation of this, guys, is also, it uses the section, which is again really nice, because you can do things also like not only two values, you can do two values skipping, and you can provide here type safe properties of this class that you want to skip. So let's look at the unit tests again. Base model test. And here you can write, for example, I have some data, but I want to convert it to map skipping the hello field. So I can just reference the hello field here in a type safe way, and I get a map of only like the second parameter. And I can skip both to get an empty map. And the same with from values. So you can see, again, it's easy to mock even the result set, and I can call my function on the mocked result set and get some data back. So because it will just map the names of hello and world to these constructor parameter names. And you can see that this class is still immutable, but you can create it nicely from your result set. And this is something that probably you would not do with Hibernate, which needs everything to be mutable. So this is like the real ORM that maps the fields to the tables automatically. So
we have a minute.
Yeah, and then let's the migration for that. I use LiquidBase, because this one is also pretty easy to implement yourself. But LiquidBase provides many features that probably would take more than 30 lines to implement. So I'm using it right now. And what goes about the transaction manager management? So that the transaction class is here again. Pretty easy class that you can create. It will store the connection inside when somebody asks for it for the first time. So this is this with connection data source with connection that all the JDBC extension used. So basically, it will try to get the connection from the current transaction. If it fails, it will open a new connection, and because this transaction is attached to current thread in a normal request thread, then I also have the transaction coroutine context here, which actually will move this transaction between the coroutine threads when the coroutine switches threads. So it's also quite easy to write your own coroutine context. As you can see, it's also only a few lines of code. And what I have already shown you where it's used is actually used, that's wrong place, roots, actually what I wanted. So actually you just tell Jupy that you want to launch all your coroutines with this context, so it will nicely pass the transaction down your coroutine. So no matter how many times it changes its threads. So that's probably, we're now out of time. I will share my presentation. I have more goodies here actually in this project, including the HTTP responses or asynchronous HTTP client, which is built in Java. But the thing is that yeah, you can look at all the code and you can maybe it will inspire you that actually you can code some things that are traditionally implemented by frameworks. You can code pretty easily, and coding them by yourself also is a really nice practice to actually understand how things work, and that is what makes you like a senior developer from like just a regular developer, if you really understand what you're doing and how you're using. And one small side note is that CodeBorn we are hiring, so look at if you want to do the pair programming and some like be fully responsible for your projects, that's then CodeBorn is really nice place to be, and you can check our website for details. Thank you very much.